self-referential classes, right? When we have studied linked list in data structures, we have used self-referential structures, if you remember, right? We used to create a node, struct node. Inside that we used to have data part, and we used to have the pointer part, struct node star next. This we used to define in a linked list structure, right? This is called self-referential structure. Why? I'm trying to create a node data. I'm trying to create a node structure with two parts. One is the data part, other is the next part. What is the data type of this data part? It is integer. Maybe I want to have an integer linked list, so I have given integer. So this is of type integer. Okay, what is this next type? Next type. Okay, now we have to go to pointers example. What is this? Int star ptr or char star ptr. What is meaning of char star ptr? Means ptr is a integer pointer variable. It is going to store address of another character variable. This is the meaning of this statement, char star ptr. ptr is a integer pointer. It is going to store the address of the another character variable. That's why we wrote char star ptr. Now in linked list, I am having this next part. It is going to store address of which type of variable? It is going to store address of which type of variable? It is going to store address of node kind of variable. It is going to store address of next node, no? This next node address is stored here. So what is the data type of this node? It is struct node type. The data type of this block, memory block, is struct node type. That's why I am creating struct node star next. I am creating a pointer which is going to store the address of next another memory block. That memory block is of type node, structure node, right? That's why we call it as self-referential structures there. And we know we can even use classes. Structure, what is the difference between structure and class? Structure and class. In both are same. In structure we can have only data members, whereas in class I can have data members plus member functions, right? It means can I use self-referential classes for linked list? If I want to create a node for linked list, why can't we have self-referential classes? Why do I always have to use this structure? I can use class also, right? Okay, how do you define that? You can have class, some class name, let me say node. Okay, open bracket, private. You can have int data. Now I want to have a pointer. Next, which should be of type of class node type. So you can write there class node star next. That's it. This is your self-referential class. Instead of using structure and creating variable for this, you are using class and you can create an object for this, right? So to implement linked list tree data structures, wherever there is a linked list implementation or tree implementation, we have to use the self-referential classes. Okay, it's our choice to use structure or class. But if you are implementing a pure object-oriented programming, then you can have a self-referential class like this: class node, private int data to store the data, and a pointer. Pointer should point to some other node. Node belongs to which type? It belongs to class node type. This is the data type of the pointer, right? So let's go and see. Self-referential classes are special type of classes created for linked list and tree based implementations in C++, right? To create a self-referential class, declare a data member as a pointer to an object of same class. See, class self, private int a, self star s refer, some variable, self star next. I can have it like this, right? So this way I can create a self-referential class. It is same as your self-referential structure. To create a linked list node, either you can use class implementation or structure implementation. See the example program, just a partial code of linked list is displayed here just to demonstrate how we try to create a self-referential class. See, class list, I have a class list. In private, I have int data. So this node I am creating, for that I have this part as data, which is of type integer. Next, list type star next. It means this is a pointer. Okay, this is a pointer, this is a pointer, this is a pointer, name of the pointer is next. What is the data type of this pointer? The data type of this pointer is another class type, another list type. Same thing. Remaining all is same. I am having constructor, parameter is constructor, destructor, insert function. Same thing. You can implement that. Remaining all is same. How you are implementing in the linked list using C++, rest all is same. Only thing, we are having the advantage, if you are using class concept, you are having the advantage of using constructors also in the class concept. Right? Now, how is the address of next node stored? It is stored using this pointer. Okay, this pointer holds an address of the next object in the data structure. This pointer holds an address of the next object in the data structure. So when you have a linked list node like this with some 10, it is pointing to another node with 20. Okay, so this, see this example here, this code, if you see, we will see the demonstration of this list insert list node. I'm creating a temporary, no, like we write struct node star temp head equal to temp. We write like this, no, struct node star temp is equal to head. Means temporary pointer I am creating and assigning the head to the temporary pointer. That way I am giving list star node, list star last equal to this. Okay, star last equal to this. This is a temporary pointer, temp. I am assigning this, means which address is assigned? Which address is assigned to this? Okay, this block's address is given here. So that is head. Instead of writing head there, we are putting this. Okay, while last next last equal to last next, until it becomes null, temp equal to temp next. I am writing while temp next not equal to null, I am writing temp equal to temp next. Then last next equal to node, that new node which I have created. It's like I am implementing single linked list, adding data at the end of the list, adding data at the end of the list. Okay, but the ultimate, this implementation we will see, but the ultimate goal here is to show you that self-referential classes means inside a class you can have a pointer which is pointing to the same class type, that is list type. Okay, so this is about self-referential classes in C++.